Good afternoon. Thanks very much for coming to this insanity of talk about DevOps. If you thought about that templates were difficult, try to prepare a talk about DevOps with live demos. So this talk is totally undefined behavior. If everything works, it will be by chance. So I'm Diego. I'm one of the Conan creators, together with Luis, my colleague there, that we have recently joined JFrog. So I'm going to talk first about the challenges that we face when we want to do continuous integration with C and C++ projects. And then I will start from the easiest things to the more complex problems that we can face. And I will try to provide like a complete solution to the problems that we want to solve. So the first thing is that C and C++ projects, because for me it's basically the same regarding continuous integration, they are typically very large, and otherwise we won't be here. So one thing with large projects is that typically we want to manage the binaries. So we don't want to be building again and again from sources. So we have to manage our binary, we have to store them somewhere and use them, our developers, but also our continuous integration systems. And this is problematic because we have the binary incompatibility. So if we build a binary with a certain compiler version, probably it won't link with a different compiler version, or with different settings, or with a different standard library. So we have to be careful about our configuration of our binaries. And also, if we are doing more than one platform, and we are doing Linux and Windows, our problem is just increasing complexity. And one of the challenging things that we face in C++ is the issue of code inlining. I think no other language has this issue. It's basically this thing. If we are developing here a very simple static library, like this one, it's just adding two integer numbers, and we build the static library, we will see that the assembler code is very simple. This Lia operation is just an optimized version of the adding two numbers. So this is my static library. Okay, that's fine. But now I'm going to build another library, another static library, math3, that is going to use math2 to add three numbers. And it's going to call twice the add function to add those three numbers. Okay, so if I build this library as a static 2, then I have this assembler code here. And what I got two calls to the function that actually lives in the other library. So this is the call, and this is the return two times for each invocation. Okay, but the code is actually not there. So when I'm building my finally executable, then it will link both together, and the linker will do the thing. So if I go now to my math2 library, and I fix a bug, or I develop something, I improve something in my code, in this case, I'm just adding a 1 there, and then I rebuild my math2 library. My code for the static library, math2, will be different, of course, taking into account this new 1 number. And if I rebuild my math3 library, the result, the assembler, will be exactly the same. Why? Because it's just linking the other function that lives in math2. So everything is fine. So if I rebuild my final application with these two libraries, it will be fine, because it will take in the modification I've just did to math2. Okay, everything good. But what happens if, for example, I build math3 as a dynamic, as a shared library? Then the static library math2 will be actually embedded in the final, because it's a binary, it's an executable code. So here we can see that our code for the add3 function, you can see the two calls. But the two calls are not calling the static library anymore. They are calling the function that lives inside the shared library. Okay? And this is a problem, because if I go to static library, I modify it, I rebuild, and I rebuild my application, it's going to use the code that's inside the shared library, not the code that I rebuild in the static library. And the thing is that it also happens for headers. And nowadays, everybody's using headers. We very like inlining things is very optimal for performance. So in this case, well, I didn't add the online, but it is actually doing the inlining here. So here, I just moved the math2 functionality to the header. So when I build my math3 library, then I can see that the assembler is not calling at all the math2 function. It has inlined everything, so it is doing the operation there. So what does this mean? If I change the header and I reuse the static library, it is using the old functionality, so I should rebuild. And this is a problem. We will see how can we build in a system with continuous integration, trying to be like optimal. Okay, so if we are doing continuous integration and we have to manage the binaries, I'm going to show you first how to create a basic package for a certain library with Conan, of course. So here we have a library with a function that is going to print some code to the standard output. It's very simple. And also the CMake file that is building this application, this static library is also very simple. So the code is there. I think everybody understands it. So if I want to create a package, a Conan package with this library, all I need is to add a Conan file.py file to my repo, to the repo where my codes live. How is this Conan file? Is something like this. Okay, so I'm going to briefly explain it so we understand what is happening here. The first important thing here is the declaration of settings. This means, okay, if I change my compiler, if I change my build type, if I change my architecture, I'm going to have a different binary. And for every combination of different configurations, I'm going to have a different binary. Okay? This is important. We will see it later. Then I have a build. The build method is very simple. It's just calling my build system. In this case, I'm using CMake because everybody understands it. But it can just directly call Visual Studio solution or any build system you want to wrap. You can just wrap it and create packages from your build system. Then you will have a package method that is just extracting the artifacts, in this case the header and the static library. All the code and everything is for Windows. So as I told you, this is going to be undefined behavior. I'm doing DevOps in Windows in live demo. So this is going to be challenging. So I'm using here lib extensions, but you can use also a extension if you are working in Linux. So it will work in every platform with very little modifications. So this is the package method that is extracting the artifacts, header and libraries, and putting them in the final package. And finally, we have the package information. This is the information for our consumers. So when consumers, they are using this package, they know that they have to link with the hello library. For example, any purposes or definitions we want to have, include directories, library directories, library names, compiler flags that we want our consumers to use, we will put them there. It will be the equivalent to PC files, more or less, in Linux. Okay, so with this file, I can just create my packages. I'm going to show you first in the command line. So I have a repo here. Okay, with the Conan file, so I can show you that I can create user testing, and it's going to build my package. Okay, so now it's calling CMake. It takes a while with the latest Visual Studio, is kind of slow. And finally, I have my package, so I can inspect. Well, actually, I can repeat this process for any configuration I want. So in this case, I just use my defaults, that is Visual Studio 2017, 64 bits, release, whatever. But if I want to build for other configuration, I just tell the system, okay, I want to create a package, but in this case, I want to create a package for 32 bits. So I will just pass the architecture as an argument, and then I will create a package for 32 bits. If I inspect my Conan local cache, I will see that I have a library here, a package here. And if I inspect this package, I will see that I have two binaries. I have one binary here for 32 bits, and I have another binary here for 64 bits. So right now I could just, okay, those binaries are cool, I want to share them with my team, so I could just do Conan upload, okay, and upload it to a server, but I'm going to do it with continuous integration. So what I just did is I developed, I created locally in my machine those two binaries. So I have a package recipe, that is the Conan file, and I have two binaries for two different configurations. Okay? So those binaries, they have an identifier. So the identifier for each package binary is just the hash of all the settings and everything that can affect my binary. We will hash in a SHA-1 signature, and that will be the identifier of the package. It will be similar to what Boost does with a certain path, for example. So in this case, if you change the compiler version, the standard library, for example, or you are building a static or dynamic, it will change and you will get a different package ID. Okay, so when you have your binaries local, and then the next step is to upload them to a server. The server, Conan also have a Conan server that is also open source with MIT license. It's fine for small and medium-sized teams, but it can also work with Artifactory. It has integration. In this case, in this talk, I'm going to use Artifactory because Artifactory has a web UI, so we can see the packages there in our cool web interface. Okay, but you can use both. So then this upload is what I'm going to automate with Jenkins. Okay, so I'm going to create my package with Jenkins. So if I want this package to be automatically created in continuous integration, so the easiest thing is to add a Jenkins file to my repo too. So I will add a Jenkins file, and in this case I'm going to use the new pipeline syntax. So Jenkins used to use an older, but now they are promoting very heavily to use pipelines. They are actually Groovy scripts. Okay, so a pipeline in Jenkins is something like this. It has some stages. The first one is very easy. Just check out the source code. I'm defining the second stage for continuous integration. This is create the package. So just the line that I wrote in the command line is going to be executed by Jenkins here. Okay. You can see that I'm running here client.run and client.run. Client is a Conan client, so I'm using here a plugin. So Artifactory and Jenkins, they have the Jenkins Artifactory plugin that will implement this helper, this DSL for us. But if you are using any other build system, just in your scripts for your continuous integration, just call Conan create, and the package will be created. And finally, in the latest stage of the pipeline, Jenkins will upload what it just built to the remote, to the server. Okay. Finally, if I want to, for example, to build different configuration at once, or better than at once, parallel. For example, I could use the parallel features of the pipeline. In this case, I want to build both 32 bits and 64 bits architectures in Jenkins. So what I can do is, okay, so I can just launch two nodes that will be identical to this here. Okay, two times, but the first one will use the x86 architecture, and the other one will be using the 64-bit architecture. So those nodes are basically the same. They are launched in parallel, and they will create both packages. So we are going to try. Here we can see our Jenkins instance. This is the lib-a pipeline. Everything is empty now. So what I'm going to do is, okay, I have my library here. I'm just going to introduce a fake commit. Sorry. Oh, sorry, wrong repo here. Okay, so I just committed some commit into my repo, and now Jenkins will detect this. It takes a while. It takes an average half a minute, to detect that the changes have been introduced, because it's using cron jobs. No, it's not necessary, because as I'm running everything locally. Yeah, so I will configure a pipeline for the next library. Yeah, so it detects that it has a new commit, and it will eventually launch. Yeah, the bad thing is that the pipelines they are running with a cron script, with cron syntax, and with cron you can go down up to a minute. So on average you have to wait 30 seconds or something like that. Come on. I don't know why it wouldn't launch. No, especially in Windows. Yeah, it worked like 2 minutes ago. I'm just going to launch the build manually. Oh, now it launched yeah, the demo effect. So it's going to build twice. What configurations? So now it is building in parallel both architectures, 32 and 64 bits, 2 times. So actually, in every row, you are building both architectures. Okay, so the only thing is that it is building twice. Okay, everything looks good. Oh, I don't know why this failed. In any case, I'm going to check in Artifactory. Yeah, and here it looks good. I have here my package, my binary for 32 bits, and here I have my package for 64 bits. Okay, so now I have set up that my coders, they can just do git pushes, and Jenkins will fire a job or a number of jobs, and it will create packages for all the architectures and all the settings I want to configure in my continuous integration. Okay, so this is what I did. Just some changes in the code, go to Git, Jenkins, and Jenkins finally will upload to Artifactory my final packages, so other users or other developers or my continuous integration system can use them. Okay, but what happens to packages that have dependencies? Okay, let's go for a new one, library B. That depends on the library A that we just created. So the B will be including A, and it will be calling A. Okay, very simple. So regarding the Conan file, all I have to do is to define the requirements. So here I maintain, okay, so I'm requiring liba, and I'm requiring liba version 100. Right, good. Then also I need some connection to the build system. In this case, I'm telling Conan, hey, I'm going to build with CMake. Please generate a CMake file for me. So my CMake scripts, they know where my dependencies are. So the CMake list will do something like this. It will include the file that Conan is generating that is typically full of all the include paths, library names, variables, so it can be used into my build. In this case, Conan will be defining targets with the modern CMake syntax. So my B library can just link with the target defined for liba. Okay, the Jenkins file is exactly the same. So nothing new here. So let's try to lib. Okay, and then I'm going to commit. But the thing is that I didn't define the pipeline yet, so I wanted to show you that actually the pipelines in Jenkins, they are very easy to set up, because all I have to do is to define, okay, I'm going to define a new item. This is going to be called lib, and I'm going to do a multi-branch multi-branch pipeline. Okay. So the defaults are all are good or almost good. So I'm just going to add my source repo. So that's why it worked in before, because I'm just doing here my local repo. And in this case, it will fire automatically because I just created the pipeline. So while it works and build libb, what is happening here? Okay, so Jenkins has decided that it wants to build libb. And it has the source code, it has the build system. So the first thing it will do, it will be to retrieve the dependencies. Okay, as B requires A to build, the first thing is, okay, Artifactory, please order the server, I need lib A. So it will retrieve a binary for lib A. So when you are building lib B in continuous integration, you don't need to build lib A again from sources. You are using the binaries from Artifactory. It will retrieve all the dependencies. If there are transitive dependencies, it will retrieve all of them. It will build a dependency graph, and it will order things and output this Conan buildinfo.cmake file. This Conan buildinfo.cmake file is the one that is loaded by the cmake file of the libb project, and it will be used to build the B binary. And once we have the B binary, then we are uploading it to Artifactory. Why? Because we are using Artifactory as our truth. So all the artifacts are always stored in Artifactory. I know we could use like another mechanism like Ccache, for example, and build locally, but this approach works for every platform. In Windows, you can just use Artifactory as your source of truth of binaries all the time. And downloading and uploading is very fast. Yeah, so the thing also that when this is working, okay, and it is retrieving dependencies, of course, it only retrieves the dependencies, the binaries that it needs. So if in this case it's building libb for 64 bits, it will only retrieve the binary for 64 bits. Okay, this matters because sometimes you have up to hundreds of binaries. Depending on what you are doing, there are Conan users that have hundreds of binaries for the same library. So if you are doing continuous, you don't want to download 100 binaries just to link with one of them. Okay, so let's see. I hope continuous integration has finished. And now I should have two packages here, lib A and lib B. And for lib B, I will also get the 86 and 64 bits architectures. Okay, so let me launch while I speak. I'm going to bootstrap some more libraries. Okay, looks good. So now, suppose that we have a more complex application, something like this. Okay, so I have a full dependency graph. I have these typical diamond structures that they are important because they can lead to conflicts. So if I go to a certain version on one branch of the diamond and I get to a different one, then I have a conflict and I have to solve it. Okay, so this would be an example of an application project I want to build. The app code will be very simple. In this case, it will be calling just C and D. If you check here, we have C and D libraries that depend on B. Okay, so my application will be just calling C and D. You can see here the main function is calling C and D, and my CMake file will just, in this case, link with two targets: the targets for libc and the target for libd. The rest is exactly the same as libb. It's very simple. So to build this application, I need also a Conan file. So in this Conan file, it's also very similar. I only have to add, in this case, I want to depend on two libraries, libc and libd. So I declare both of them. Okay, I'm adding also a line here in the build method to run the binary that I just built. It's just for convenience. So I'm going to build things and I want to see the output of the running application. And also the packaging, but this is not important. So let's check if this has finished. Looks good, and everything has been uploaded to Artifactory. Okay, so I'm going to show you I'm moving to a clean folder to build my project. Okay, so what I'm doing here, I'm not going to create a package. I want just to develop. So I'm going to use this Conan file just as a recipe to retrieve my dependencies. But I will be working locally. I'm not creating a package anymore. So I will be just Conan installing my dependencies. Okay, I got my dependencies, and I'm going to execute Conan build. This is just a local build of my application. It will be the same if you run CMake manually. It will be exactly the same. Okay, so here I can see the output of lib_a is being called twice because of any side of the diamond. Okay, so everything is working here. So I could repeat the same thing. I could just wipe this Conan install for 32 bits. Conan build. And what I'm doing is I'm just retrieving my dependencies for 64 bits, for 32 bits. And I'm calling one or the other. Okay? So for me, this is amazing because actually I can have a different dependency graph depending on my architecture or depending on my operating system or whatever. So I can check here, for example, my dependency graph. Oh, sorry. 2 dashes. So here you can see my project here depending on C and D, which in turn depend on B. So the graph that I showed you in the slides is just what the tool is giving me. So you can check that this is real. Okay, so far so good. The challenge, the real challenge, is when we start to evolve our dependencies. So what happened if I now go and I do an amazing improvement to my code and I generate this awesome message, okay? Cool functionality. I'm going to release a new version. I'm going to release version 101 for lib_a. So I go to my Conan file and I bump the version and I create the package. Sorry. Release 111. Okay, I got this. Then I do my commit. I'm just going to fire it manually, so we don't have to wait. And now it is building my new version. It's building 101 for lib_a that includes the new functionality. So now in a while, we should see that for lib_a now we have 2 packages. We have version 0.0 and version 0.1. Okay, and for each one, I have 2 binaries. Okay, for 32 bits and 32 bits architecture. Okay, so what I have right now is this. I have created 2 packages. Two different packages for 2 different versions of lib_a. But if I go to my application and I build my application, it's still going to show the previous code because my dependency graph is that. Okay, so what could I do? The typical thing and the thing that most users are doing is this. Okay, so it will be the manual update of the dependencies. Okay, so let's say that now I want to use the new functionality from A. Okay, so I will go to B, and I will bump here my requirement to lib_a. Okay, and then I will bump my own dependency of libb. Okay. Actually, typically you will also do some source code changes, but not always. So you can just bump your version and fire your build, and you will have this here. Okay, so we are going down the hierarchy here, one by one. It is good. It is an ordered way to do it. We will be testing everything, but we will be slow. Okay, is it possible to do something so we can go faster? So here the challenge is how to update dependencies when the source code doesn't change. Actually, in this example, I haven't changed the source code for B at all. The source code for B is exactly the same. So what can I do? There are different ways to update your dependencies upstream. The first one is to be explicit and just bump the versions manually, one by one, and keep running. There are other ways. For example, there is one that would be like server-based, or let's say defined by the package creator. You can have an alias. It's basically like a symlink, or so the package creator defines, okay, I have this for example, version 1.0, and this is a symlink. This is an alias for the latest version of the package actually. So every time he created the package, he can update the alias. And updating the alias, it will make the consumers of that alias to retrieve the latest version of the package. Okay? So this is something to retrieve the latest version of a certain package, but defined by the package creator. Okay? Then we also have version ranges. Version ranges is the typical expression. You can use the approximate approx of a node Semver, for example. You can use and or different conditions there between the brackets. Version ranges work nice, but typically it is slow, for example, because it has to check the server, to check all the versions that it can match, and then evaluate the expression. Okay. So in this talk, I'm going to use version overriding. Version overriding is something like this. So when I'm developing my app, okay, so this is the Conan file for my app. It's the downstream final package of the dependency graph. Okay, so I'm going to introduce another requirement to liba, and I'm going to force that liba. I want to depend on liba version 1.01. That is the one that I want to test for my final application. And then I'm adding here an extra word, is override. Why this word here? Because if I don't add this override, my dependency graph will change. I will add an edge between my app node and my liba node. Okay, so it can matter. For example, it can affect the order of my libraries. You know, when you link, your libraries have to be in order to properly link. So if you are doing these kind of things, you are changing your actual dependency graph. And if you are doing some analysis, you say, hey, why my app is actually depending on A? It is not depending on A. It is depending on C and D. So I don't want this edge in my information here. It won't help me to refactor. It won't help me to move. So that's the reason we can specify override. And if I specify override, it will only change upstream. Okay? This can also matter because Conan has also conditional dependencies. It will have dependencies that can change from operating system. Typical case, electric fence in Linux, and you don't have it in Windows. So you have packages that will depend on electric fence on Linux and nothing in Windows. So that your dependency graph actually changes from configuration to configuration. And in that case, you definitely don't want to introduce a force requirement upstream because you are just trying to update a dependency. So the override is, okay, if you upstream, you find dependencies to liba, use this one. Use liba 101. So the override here the override works like this, just as I showed you. So I'm going to my app, and this is Conan install. You can see here that now I am depending on liba 101. Oh yeah. Good. So now we can see that we are using the new message from liba. So my whole dependency graph is working with this new liba. And I didn't have to rebuild any of the nodes. I didn't have to rebuild B. I had to rebuild C or D. Okay, so everything linked and everything worked. But this might not be the case always. For example, something that we do a lot. Let's do something more amazing, and let's do optimization. So I'm going for a new version, and I'm going to inline the message. Okay? As this is a bigger change, I'm going to bump my version to 1.2.0. Okay, good. Let's do it. First, I'm going to create the package for 1.2.0. Okay, let's check it that is here. Good, I have the 3 versions here. So now I can go to my project, I can override, and I want to say, okay, I want to build with 1.2.0. Let's try it. Oops. So something failed. What is happening here? So why did I get this link error? And I was very lucky that I got this error. Yeah, you know it. Otherwise, the debugging the opposite, that it happens a lot, is a nightmare. So what is happening here? I have 3 versions of liba. First 2, they have in the native code of the static library, I have implementation for A. Different, but I have implementation for A. Okay. If I go to the 3rd version, 1.2, I don't have an implementation for A, because implementation for A is in the header. Okay. And then for my library B, static library that I built, it had a jump call to static library A. So when I linked my final application with liba 100, it links with it. And it will call, my application will call the code from liba 100. And if I link with 101, it will call the code from 101, and everything works. But if I try to link with the 3rd version, it won't find the A code, and it will fail. It will. So, why I said that we are lucky, because if we just did changing the code in the inline header, my code will link, but it will run the old version of the code. And then I will have to debug and know what is happening at runtime. Good luck. So what do I need? What I don't need is this. If I want to keep my library B, and I don't want to bump the version because I haven't changed the code for B, the source code, I need 2 binaries. Okay, so I need a binary, okay, that will be able to link with the first 2 versions, and it will contain a jump to the static library of A, and then I need a different binary for library B that has the code inlined of the library A inline version. So this. Okay. How can I manage to do this? Okay, when I presented the package ID, I omitted the latest thing. So one thing that changes our binaries are our requirements. It's something that doesn't happen in any other programming language. Okay, and yeah. So how do our dependencies affect our binaries? We don't know. So what we did in Conan, what it's doing is, okay, it's assuming Semver by default. Okay, so if you are bumping the major version, you will need a new binary. But it happens that it might not be good always. So for that, Conan allows to configure your binaries, the binaries you need. In this case, for example, I will explain with the settings. We have here the default package ID for the settings, and the default behavior is, okay, for every compiler version, you will get a different binary. Okay, so for GCC 4.8, you will get a binary. For GCC 4.9, you will get a binary. For 62B, you get a different binary. Okay, and that's true. The compilers, even if they are compatible sometimes, you get a different binary because probably they implemented some optimizations or whatever. So the final binary you get is different. But what happens if and it's a real use case? Some people, they are packaging a C library, okay, and say, hey, my API won't break. I'm fine. I want to build my library with GCC 4.8, for example, and I want to reuse that binary for all my compiler versions. And I want to do it. I don't want 10 different binaries. I want one. So in that case, with the package ID, you can do it. You just override the default behavior, and you say, okay, so the information that is going to affect my hash, my package ID, will be, instead of using the version, use this string, use any. So what you will get here, you will get, okay, so with this package ID, you will get just one binary. Of course, one binary for this setting. If you are going to Windows Visual Studio, you will get a different binary. But for this setup, you will get just one. So the same can be applied for requirements. The default behavior for requirements is Semver. So every time you change the major version, okay, you will get a new binary. What happens that I think in C++ we don't follow semantic version at all. Why? Because if we did, we will have version number 3100. That would be the major. And every time we break the API, things like that. So we typically tend to bump the major is typically our minor in C++. So if we want, okay, so I want this behavior. I want any time my dependencies bump the minor version, I want a new binary. It's just what we build. So you can specify in your Conan file, you can specify that with this syntax here. This is just a helper. You can define your own logic here if you want. But what it means is this. Okay, when it is evaluated, if it is depending on lib A 100, or it is depending on lib A 101, then the patch is discarded. So you get the same result. You get lib A 10 set. And this always hashes to the same package ID. So for both cases, for both minor versions, you will get the same package ID that will be the package ID of the binary containing the jump that is able to link with the static library. And in the other path, here, if you are requiring library A 1.2, it will be changed to library A 1.2 set, and it will hash to a different package ID. And this will be the package ID that has the implementation in line from the header. Okay. So now let's try to do it. The lib. I'm going to lib. I'm going to modify my Conan file. Commit. and I'm going to fire libb. Sorry, come on. It doesn't matter. It is the comment of the commit. It will work. So let me just build. So what I'm doing here, right now I am overwriting. I introduced a change. I submitted without bumping the version, so I am rewriting my old binaries. Okay, it also can be done. So now it is rebuilding my libb, and I'm going to try to use it from my application. Let me make sure that everything is clear here. Yeah, sorry, I forgot to add the. Oh no, is the override is already to 1.2.0. So I'm going to install. Yeah. And now I got a different message. Okay, it's still an error, but it's a good error because now it's telling me that you don't have a binary for libb. Hey, I just created a binary with a continuous integration. Why? Why I don't have a binary? Because now I'm trying to use a binary of B that will link with libA120. So I need that binary. Nobody built that binary. So what I can do here is I can do myself. Okay? Just build that missing library. Build that missing package. Okay, and now it's working. And the important thing here is that I haven't messed up with my binaries. If I want to revert to my old 101, I just do the override. And it will work without rebuilding anything at all. It will manage all the binaries, and we can check in our cache that for library B, we have this. We have two binaries, and you can check. Here we have a binary here that is requiring libA100, and I have a different binary for libA that is requiring library A120. Okay. Yeah. So now I'm going. This is the interesting part of regarding C and C++ is almost done. So here I wanted to just to do some proof that what can be done, but this is mostly just Jenkins. Okay, so I'm going to do it quickly. So I prefer to keep some time for questions. Okay, so actually, if we want to scale this to projects that instead of having 5, we have 50 or 100 dependencies, I would like something like this. I want to test my whole application rebuilding with library A12, okay? But I don't want nodes like libE, for example, that is not affected at all. I don't want it to be launched. I don't want to be computed, okay? I want to launch every single node in a Jenkins job, so I can visualize all the hierarchy going, okay? And I want to launch them in parallel. Okay, so what can be done here, Conan has a command that is the Conan information. Conan info will get information for the dependency graph. In this case, you can ask Conan what will be the build order you need to build such dependency graph. So it will tell, okay, you have to start with A, then you have to go to B. The return actually is a list of lists. Why? Because a dependency graph actually is a directed graph. So you can order it, and you can order it by levels. all the nodes that are in the same level, they can be built in parallel because they are independent between each other. Okay, so in this case, the algorithm detects that C and D are not dependent in each other, so they can be built in parallel. So with this, just building a continuous integration system is very simple. It will just use a recipe with some tricky mechanism to define the overrides I want and to propagate them to the whole system. But basically, it's what you saw, and we will be using a Jenkins job that will be firing all the children for every node of the graph. So the script is like this. Don't think that it's 200 lines, so it's something like this. But if you check, most of it is groovy. Comes from Java and things. It's verbose. So, but here, what you have is you're just calling Conan info to get the build order. Okay, it is being saved to a JSON file. The JSON file is being loaded, it's being parsed, and you get the build order as a variable. And then it is just launching the children in parallel. So it's doing nothing but just launching things. And the children is almost the same as we saw for a single package. It's just the initial step is a bit more complicated, just to define an intermediate Conan file, but the install and the upload is basically the same. Okay, so in this talk, in the abstract, I wanted to talk about other things. For example, I want to talk about build requirements, because another way to speed and to ease in our continuous integration is to define, for example, our tools. We could do things like this. We can depend, for example, on Catch testing framework, and we can do it as a build requirement. That means that it will only be retrieved and it will only be used if you are building the package from sources. So if you already have the binary for this certain package, Catch will not be retrieved at all, and it will not be used. This is interesting because it can be used not only for testing frameworks, but also for tools. So this is something that typically our users are doing. Imagine you want to use latest CMake 3.9. You have two options. You can ask your IT to install CMake in the servers, then wait for 2 months or 3. You know what I'm talking about. Or you can just take CMake 3.9, build a Conan package with it, upload CMake 3.9 to your remote server, and then you can inject this build requirement in your profile, for example, or in your recipes. So then, when you need to build from sources the package, CMake 3.9 will be retrieved. The path to CMake will be injected in your recipe while it's building, so it will use CMake 3.9 from the Conan package. So the result is that you can, in a dependency graph, you can actually build different nodes with different CMake if you want. And this can be, of course, generalized for compiler. There are some examples with min.gw that are also very interesting. So if you want just to build with GCC in Windows, you don't have to install it. Just create a Conan package for it, and it will be used. So of course, very useful for developers. If you don't want to be installing things and you want to run against different GCC versions in Windows, for example, you can do that. Okay, so my conclusions here. The first part is automating the creation of packages is very simple. Just with 20 lines of a Conan file that is practically always the same, and 20 lines of the Jenkins file that is always the same, you can create packages when users do git push to your repos, and it will work for multi-platform. The packages will end in the server, so this is kind of easy. For the challenging task, there are ways to do it. So if we define correctly our versioning approach, if we define correctly our package ID, and we define some updating mechanism for example, dependency overrides or version ranges, whatever, we can make it work that it will be optimal, in the sense that only those packages that really need to be rebuilt will be rebuilt. The rest, you can have a hierarchy of 50 packages. Only those that really need to be rebuilt for compatibility and for using the right code that has to be used will be rebuilt. Okay, and of course Jenkins offers a parallelization over the nodes that are independent and everything, so this can be actually pretty fast. The only thing here is quite functional. This is a proof of concept, but this is quite functional. Is some usability. So I had to use a couple of tricks to actually propagate the information about the overrides, for example. So here I would love feedback. So if anyone is that is using Conan, is using continuous integration, please submit issues. This is really something that we are working on, and the more feedback we have, the best for the next versions. And finally, I didn't want to finish without saying that we are hiring. So please send your CVs, come to talk with us to our booth. By the way, we also have t-shirts. We have these t-shirts in our booth, so if you want one, please come to our booth, and we will love to give you one. And yeah, time for questions. Any question?
Trust me to pick the seat furthest away from the microphone. So I have a quick question about the semantic versioning aspect. You mentioned that the default was to use semantic versioning.
Yeah.
That seems extremely dangerous given how almost impossible it is in C++ to get it right. Given everything's, the propensity towards putting things in headers, and the fact, as you demonstrated, that's exactly the kind of thing you can get wrong. So what was the motivation between picking semantic versioning as the default rather than making it the override?
It was basically like being purist. I mean, semantic versioning says that we should do that. And then we introduced it, and when we realized that probably we should have gone for a more restricted approach, then there were thousands of packages up there with the binaries. And if the thing with that is that if we change the default that we are using for hashing and computing the package binaries, then all the binaries that are uploaded to the central server, they will be broken. I mean, you won't be able to find them because the package ID will change. We are thinking probably for version 1.0 that we might be able to break more things. We might consider doing a more restrictive versioning approach.
Cool. I would strongly suggest doing that. It's caused nothing, but the debugging of that problem is nearly impossible. A second thing, I didn't realize I have people behind me. If you don't mind, I'm going to sneak one more in. It looked like that the depending package was the thing that determined what the version was. Whether it was using semantic versioning or not, whereas it should be the package itself that defines whether or not people who depend on it should pick up on semantic versioning.
Not really, because the thing is, for example, if you're the package that is depending, okay, it can say, okay, I'm going to build a sharded library. Then I have to, every single change in the version of my upstream dependencies is going to affect me. Or I can build a static library. And now the minor patches, they won't affect me. So it's actually the
only if you know how that library was implemented yourself, because the library itself knows whether it has things in headers that need to be. I guess we should take this offline. Really, I think I can probably talk about this forever.
Actually, there are two sides. First is that the package that is being depend on is following some versioning approach that you understand, and then the package that is using that package is the one that says, okay, I'm a header-only library. So my upstream doesn't define how it's affecting me. I do it because I can, for example, boost, I can just do a header-only. I will build a package for a header-only boost, or I will build boost for static or dynamic. The way I build boost is the way that defines how my upstream affects me.
Cool. I get it. Maybe both packages should be involved in that decision. So I'll defer to someone else now. Thank you.
So I have a question about your experience with this in terms of having code bases of scale. So have you guys had any experience using this on a code base that's like millions of lines of codes and like over 100 packages that are like all highly changing all the time?
We directly don't, but our users, we have users that have more than hundreds of packages. So the approaches, I would say, every approach of every company is different. So some of them, they will try approaches that will be very like living on the edge, and all the packages, they move all together. So for example, when you update lib A, and bump the version, they will have a script that it will bump the version of all the dependencies downstream, for example, and they will move everything automatically, for example. Others, they are doing it manually, and they don't care. I mean, if we are upgrading this, it can take 1 month, but we want to make sure that the changes upstream are tested one by one down the hierarchy. So I know that it's being used. Actually, when I said the version ranges approach is a current issue, because some people that are having like, one of them was having like 70,000 artifacts there. I say, hey, my version range is slow. Yes, you have to search the version that matches this for several hundreds of packages. So this is a known limitation, for example, and that's why we developed the Conan alias. So yes, I couldn't extract like a general pattern for larger scale projects, because everyone is doing something different.
Okay. One question about like the fact you use exactly strict version for your dependency. Like when you do require, you specify exactly the version, or not something like version superior to that. Like one problem with that, because your system is very similar to the Python packaging mechanism like pip, is generally when you start to have very big tree of dependency, you get at least like one library which is used with 2 or 3 different versions. Like how do you handle that?
So you are talking about versioning conflicts?
Exactly. Like in case of static library like you have, it's a bit obvious because it's not going to compile. In case you are using shared library, you get really, really nasty side effect when you have that.
Yeah. So I think with regarding that, Conan is following, let's say, quite a standard approach. So it is using the typical conflict detection and resolution. Actually, not only versioning. The thing is that you can have conflicts based on configuration. So you can have a package that is being used. Hey, I want to link with this package statically. And then on the other side of the diamond, I want to link with this dynamically. So what? So that's a conflict, and it has to be resolved. So what Conan does is, okay, one premise of Conan is it doesn't try to do a lot of magic. So if it detects a conflict, either of versioning or configuration, it's going to tell the user. And the user downstream is the one that says, okay, so I have a conflict here, I want to use version and doing an override. The override typically is a mechanism for resolving conflicts. So the same override you can do there, you can do for options also. And you can force downstream, okay, you want static, you want dynamic, I tell my dependency graph that you are going to use dynamic. There is also a different kind of dependencies in Conan that are private. So you can use private dependencies, and so you can actually depend on different versions in the same dependency graph, but they will be different nodes. You really want to make sure that the API won't cross frontiers here, and you won't share objects of those libraries. It's typically something you don't want to do, but some users, they really need to link with the same library to different versions in the same dependency graph. So it's something that can be done, not something that would be recommended for the general case.
Okay, thank you.
Thank you.
So we have a mixture of C++ and Java code in our code base. We use Maven for building the Java. Is there integration with between the sort of the Maven artifacts and the Conan artifacts?
Okay, so there is no integration with Maven. Okay, but Conan, as you have seen the recipes, they are just very general. So we have proof of concept working for Python packaging, also for Golang packaging. There are also a generator for Rust. So from Conan packages, you can just generate all the information of certain dependencies that will be used from Rust to link with the artifacts that you just created with Conan. So I guess for Maven, you can do that. It's possible to write a generator that will output the information of the dependency graph and everything that Maven needs in Maven format. It can be built in one day, for example, such a generator.
Okay, cool, thanks.
Hey, Diego.
Hi.
I noticed that in your first example, when you override the version, Conan just failed instead of recompiling. Does that mean that the default policy is not to check the version and recompile the dependency if the graph changes?
The default, when I did the first override, you mean?
Yeah.
Yeah, the first override was a minor. Actually, it was a patch.
Oh, and the default is to do not recompile, right?
The default is Semver. So Semver, if you're just bumping the patches, Semver will tell you that you don't need to rebuild.
Yeah, I agree with that. Okay. Just to add to maybe a bit of response to what Matt said just before with Semver and the problems of versioning. I'm doing a talk on Wednesday morning about versioning in C++. I will be very glad if you come and you can give me your feedback. If I can give you answers, I would be very happy.
Cool, thank you.
Looking at the CMake use cases, that it seems that it's duplicating a lot of information that would already be available through CMake's install process or the CMake modules that get generated when you install a library. Is there any way to have Conan extract that information rather than repeat it in the Conan file.py? Things like, sorry, I should clarify, things like required compiler flags, for example.
No, I mean, Conan is very orthogonal to the build system, so it's kind of transparent, so you have to translate all the way down to CMake and also starting from CMake. Of course, you can do many things. For example, a typical use case would be in CMake, you have the install, for example, utilities. So instead of defining your package method in the Conan file recipe, you just call CMake install, for example. And so we have the parameters like the package folder, and you will say, okay, CMake install prefix package folder. So it will run the install to the package folder, and so you can reuse that functionality. So basically, it's up to you. There's nothing transparent or magic in the way that we are integrated with CMake. Just you call CMake to generate packages. You can pass CMake any flag you want, but your CMake script, it has to be prepared to use those flags.
Yeah, sorry, I meant the other way around. So if your CMake for your library is defining flags, you need downstream, the typical way in CMake would be install generates a module file.
Yeah, so basically, imagine that your CMake is requiring some preprocessor directives or something. You have, right now, you have to add them manually in your package information. So for your consumers, Conan will not detect the configuration from CMake. You have to explicitly define for your consumers the configuration in the package info method. So in that way, you will have some repetition, but there is no way that you can do this very smartly. I mean, extracting the information for CMake is not something that can be done automatically. In any case, it takes you like 2 minutes to do it. If you know your build system, building a package recipe is quite simple.
Okay, thank you.
Okay, thank you. Anyone else? No? So thanks very much for coming.